Hello, once again, Isa-Ssekandi is my name. I want to take you through the second session about bacteria. From the structure of bacteria that we looked at, we can derive a few aspects about their features. So what are the features of bacteria and prokaryotes in general? First of all, they have 70 S ribosomes. Which are smaller than the 80S of the eukaryotic cells. Two, they have no nuclear envelope on their DNA, on their nucleus. Three, they have naked DNA, naked DNA, i.e. their DNA lacks proteins, doesn't have the histones and the other proteins that are associated with DNA. Four, their cell wall is made up of peptidoglycan. This is a combination of polysaccharides and peptides. It's a combination of polysaccharides and peptides. And also these prokaryotes, compared to the eukaryotic cells, which can be as large as 120 micrometers or 150 micrometers, these ones are so tiny. They range from 1 to 5 micrometers. An example is the bacteria Escherichia coli, which is commonly known as E. coli. E. coli is as small as 2 micrometers. So that's how small they are. So all of this can be traced from the structure that we looked at in our previous episode. When you look at the structure, you can see the 70 S ribosomes, how naked the DNA is. Actually, the nakedness of the DNA makes it known to be in the form of chromosomes. So the DNA is found within the cytoplasm, within the cytoplasm, and it's not organized into chromosomes. So we look at classification of bacteria. How are bacteria classified? So classification of bacteria. So we do classify bacteria. First of all, we do have classification based on gram stain. So how do bacteria respond to gram stain? We do have those that respond positively, that is gram-positive bacteria. There are those that respond negatively, that is gram-negative bacteria. It simply means that gram-positive bacteria, when stained with the gram stain, the violet color is associated with those bacteria even when the stain even when the bacteria stay for some time. However, the gram-negative don't retain the stain. So the stain, when the stain is put on those bacteria, their cell walls don't retain them. And we know below that we can look at the reason as to why that one is true. The gram-positive bacteria have a thick peptidoglycan layer in their cell wall. So this thick peptidoglycan layer can retain the gram stain. Then we do have the gram-negative bacteria. These ones have a thin peptidoglycan layer. This one, being that the layer is thin, their cell wall is generally thin, it cannot retain the gram stain. It cannot retain the gram stain. So, and we do have examples of such bacteria. The gram negative, so the gram positive bacteria are those of Staphylococcus. We do have Staphylococcus. An example is the Staphylococcus aureus, the one that causes respiratory tract infections, several of them. We do have Streptococcus and others. Examples of gram-negative bacteria include E. coli, Escherichia coli, which was discovered by Professor Escherich in the year around 1887. Then we do have Neisseria gonococci, which causes gonorrhea. That's classification based on staining. Classification based on respiratory mechanism. Based on respiratory mechanism. There are three types of bacteria in this based on this mechanism. We do have obligate aerobes. We do have obligate anaerobes, and we do have facultative anaerobes. Obligate, compulsory; facultative is option. So obligate aerobes, these ones can only survive in oxygen environments. So without oxygen, they can't survive. Examples of such bacteria is the Mycobacterium tuberculosis, which causes tuberculosis. Obligate anaerobes don't completely like oxygen. In oxygen environments, these bacteria can be poisoned by oxygen-free radicals. So they lack peroxidase. They lack peroxidase and catalase enzymes. So such bacteria include the Clostridium tetani, which causes tetanus. We do have facultative anaerobes. These ones can stay in oxygen containing all oxygen-free environments, and usually they are parasitic in nature. These are mainly found in gut, in gastrointestinal tract, and other oxygen-free areas of the body. They include Staphylococcus aureus, Streptococcus pneumoniae, and Clostridium botulinum. So these ones, we said, these ones need oxygen, these ones no oxygen, and these ones it's optional to them. So here we do have Clostridium botulinum, Staphylococcus aureus, and Streptococcus pneumoniae. Which causes pneumonia. So this can give us a clue on the habitats of these bacteria. Obligate aerobes are found in open space, in ponds, in shallow waters, and in those different open spaces, because they need to be supplied with oxygen. That's why the Mycobacterium tuberculosis, which is found free in the air, can easily be taken up by an individual, simply because in the air oxygen is freely available. Then obligate anaerobes, these ones as we said, they don't need oxygen. Like the Clostridium tetani can inhabit the deep end of a wound where there's little oxygen supply. Then we do have facultative anaerobes. These ones, their life is so optional. However, they are mainly found in gastrointestinal tract and the respiratory tract. E.g., Staphylococcus aureus, which is found in the upper respiratory tract of mammals. So we look at the last bit of this section, that is biological importance of bacteria. These bacteria. How important are bacteria? We do have areas of genetic engineering. Areas of genetic engineering. Here we use these, many of these bacteria are used in DNA recombinant technology. DNA recombinant technology. E.g., the bacteria E. coli is widely used in such experiments. In the biotechnology, e.g., synthesis of vitamin K, and riboflavin. Using E. coli. Number 3, bioremediation. In Europe, several pounds of bacteria are used to treat large oil spills. This has been used in modern bioremediation processes. So bacteria that mainly grown and they are specific to certain oil hydrocarbons, they can easily be sprayed or inoculated onto large oil spills, and then they decompose those hydrocarbons into smaller manageable particles. Number 4 is antibiotic manufacture. Like penicillin from Penicillium. Number 5, indigestion. Bacteria found in the gut of ruminants is important in digestion. That is the cellulase secreting bacteria. In the food industries, bacteria has been widely used in the manufacture of food products like milk products, e.g., lactobacillus has been widely used in manufacture of yogurt. Then in the leather tanning industries, softening and improving leather, bacteria are inoculated into leather pieces and they soften all small protein particles that are found associated with the leather, hence improving its properties. Then lastly, bacteria has been widely used in fiber separation in fiber industries. Thank you so much. Stay tuned in for the next item.